I'm Dave Bowman. I work for the Esri DC R&D Center, and with me is Mike Juniper, also of the same place. And we're going to be talking about functional JavaScript for Sane applications. So a little bit about a journey as a developer. I'm at dbowman. That's dbowman@esri.com if you want to email me. At dbowman on GitHub and on Twitter. 20 years as a developer. I did the first 15 of that as a consultant. Last 5 years I've been at Esri, helping build open data and now the hub. And there's a little bit of a difference between these two environments that I've spent my career in, right? As a consultant, your job is pretty much to swoop in, help solve a problem, get the code written, build it, ship it, get it out, move on to your next project. Not to say that when we were doing consulting work, we weren't necessarily super concerned about stability and things like that, maintainability, but it's different because you're moving on to your next project. At Esri, we ship products. These products have long lifespans, and so there's a little bit of a different mentality in terms of what we're optimizing for as a development team, right? We need to make sure that we're shipping on time. I see Andrew Turner here. He likes it when we deliver the things he tells Jack that we're going to deliver at the time frame that he's told him. But we also need to optimize for maintenance because we're the ones who are going to be taking care of this code over time, as well as flexibility. At Esri, we're a big company. We have a lot of things in flight. You've been here this week. You've been to dozens of sessions about all kinds of different products. And those things are all moving on their own time frames and their own time scales. And one of the things that Hub does is actually orchestrate a lot of the platform. So we have a lot of moving parts, and we're touching a lot of different aspects of the system. So when we write our code, we have to make sure that it's something that we can reason about when we come back to it. So this has really brought me around to embracing functional programming. And so what is functional programming? Well, let's talk about that, right? This is a style of programming. It's not new, though. It has its basis back in the 1930s when Alonzo Church was working on the lambda calculus and Haskell Curry was working on combinatory logic. And together, these two mathematicians were really trying to put together what we call a system of computability. And this system of computability, this is like before there are digital computers. They were doing this with pencils and paper on chalkboards. And they're writing math, right? Mathematical functions. The interesting thing about mathematical functions, right, is they're focused on data transformations. So you have an equation, you go and you substitute values into one side of it, you do the computation, and out the other side comes a value, right? So that is an interesting thing. And when you're doing this on paper or on a chalkboard, it's a little bit different from when we do this in a computer. In a computer, you can have shared state and global variables. I don't really know what a global variable is in terms of a chalkboard. Is it like, there's a chalkboard on the other side of the room and suddenly I can start putting values to it or pulling values from it? So when we talk about this same concept, right, these mathematical functions applied to software, we had to call them something different. These are pure functions. And we'll talk more about pure functions, but this is really the essence of what functional programming is the abstraction and making sure that you're composing things out of these functions which follow a set of rules. The net result of this is that you end up with software that is very robust. It is easier to maintain because it is easier to reason about the software, and it's composed out of smaller pieces, which are themselves just easier to understand and work with. You can do functional programming in many, many languages, right? Hopefully, maybe some of these are things you've seen or are familiar with. You get your Haskell, your Erlang, your Scala, those sort of things. These are purely functional languages. We're going to be talking about JavaScript, but I think it's really interesting. JavaScript falls into this category of functional programming capable. But functional capabilities are coming both to Java and C#. Your big enterprise systems, which have been really dominated by creating giant class hierarchies and tons of interfaces. So why is it that those languages are actually implementing these types of features? Why is that of interest now? Why are we adding these things to C# and to Java? Well, it turns out, and I'm sure if you've bought a computer in the last few years, you've noticed this, that your computer itself is not getting faster, right? Your 3.4 gigahertz chip is probably very similar to the one you had a few years ago, but what's different is you get more cores, right? This is the way that we're scaling compute. We've hit a certain limit with how small we can make those connections and how hot they can run, so we end up putting more cores on things. It turns out, pure functions parallelize. That's a really important thing if you want to make use of all of those cores. So if you have a situation where you have a list of 1 million things, or you had 1 million geometries, so on and so forth, and if you can work with a pure function and pump it through something like a map, you're able to run that across all of the cores. Now the asterisk here is to say that JavaScript today is not doing this, right? But this is why people are using stuff like Erlang and Haskell and using the functional capabilities within Java, because then the JVM can start doing this. If you're running Scala, these are the benefits. And in certain languages, right, this abstraction is extended to run across an entire cluster. An example of this is Erlang. So I don't know if anybody has ever heard of WhatsApp. It's a little application out there. You know, when it got sold to Facebook, it was running just about 1 billion users, and they had an engineering team of 50 to run a platform like that. That's a pretty good payout, I think, if you're one of those 50 engineers when they got bought. That's a good slice of the pie, isn't it? But they run on Erlang. And it enables them to massively scale, and they get this parallelism that's really powerful for them. So if you're interested in this, just Google WhatsApp and Erlang, and there's a whole bunch of info about that. So let's get back to JavaScript, because that's the name of the talk, and I better start talking about that. Let's talk about JavaScript apps. JavaScript app, let's pick this app. And it doesn't really matter what sort of way that you've built your app. You know, you may have these components. Those components may be classes. They may extend things. But you start to have references between things, and things start sending messages between the different visual components. And you know, more and more messages get sent. Maybe you're starting to share some state inside your application, because it's an expedient way to build the app. And you keep building your app and start putting more UI in it, and that UI, of course, needs access, and it's sending more messages to other parts of the app. I don't know, how many people have built this app? Right? We've seen some things like this. How many people know what happens next, which is when you go to try and edit your app or make a change to it, you have this happen, right? All I did was change this one thing over here. I called that method again, and this other thing over here blew up. This has a lot to do with the shared state, mutation of shared state by multiple parts of your system working together. A functional style can really help reduce these risks, right? We're not going to talk about being a functional purist here. It's functions all the way down, and that's the only way we're going to do it. That's just really not reasonable to do. We're going to talk about how can you apply a functional style into however you're building your apps today to just make your life better over time. And we're going to do that in some interesting ways. The other thing that comes along with this is that you end up having more reuse of various components of your application. And hopefully we'll see that. But on the upside, if you think about it at a library level, if you're using functions, it's kind of cool because you can import just the little pieces that you need. Right? ArcGIS REST JS and hub.js and the coming Solutions JS stuff, they're all based on this exact model. We had we gave 2 talks on this stuff yesterday, so if you have a time machine, you can check it out now. Otherwise, wait till sometime in April when those talks will be on YouTube. But the point of this is that when you use these imports and you have just a library full of functions, your build system, Webpack and Rollup, is going to just only pull those into your application. Now that's good, right? Because the less gets packed into your app, it's a smaller payload going over the wire, it's faster to parse in your browser, it's faster to boot your app, your people are happy in the end, right? So that's awesome. Now, maybe you're still a little skeptical, right? No, I don't know about this stuff. Functional programming is very core to both React and Angular. What I'm trying to tell you is that you can't really escape some aspects of functional programming if you're going to be working in the web today, right? React's core idea that the user interface is a function of the central state, that is a functional idea. I mean, ideally what they really want you to do is make the UI a pure function of the state of your application. Redux is based on the idea of using reducers. A lot of the constructs inside React and Redux are based on these functional ideas of composing function chains together. Angular has RxJS built right into it. That is a reactive functional programming library. Like, it's at the core of how these things work. If you want to be really productive with these frameworks, understanding functional approaches is really going to be helpful. Now, you say, Dave, what about ES6 classes? Right? We have ES6 classes. We should use these. Isn't that great? Well, you can. There's a couple of guidelines about it, right? First, avoid inheritance. If you want to make a big object model, right, that's great and it may work well for your application, but odds are pretty good that the abstractions that you put into that model are not going to be directly reusable on a whole lot of other things unless you're rebuilding the entire app, right? So there's limits to reuse in that area, and you end up having brittle hierarchies and end up copying and pasting code and having duplicated code that's really similar but not quite. There is, of course, an exception, because all rules have to have exceptions, and that is, go ahead and extend the components that are part of the framework that you're building, right? If you're going to use a React UI, you're going to extend React component. But again, don't create your own hierarchy of these things, because odds are pretty good that that's going to be break over time. Instead, the recommendation is to use what we call composition. Now, composition, oh, that sounds like a special thing. Anybody ever used a mix-in? It's that exact idea, that you take an existing object, just to, take a Pojo, turn it into, an object, and then just start welding things on the side. What's cool about this is it gets you around an inheritance hierarchy, and you can just mix and match the pieces that you need to compose it into the object that you really want, as opposed to being like, oh, I got to go up this inheritance tree. So that's really cool. The other final guideline in this area is to use factory functions instead of new. And the simple reason for this is that if you go and create a bunch of classes and scatter new foo all over your code base, and then you decide, yeah, that hierarchy I created is not going to work for me, I need to go and switch to a more mix-in or compositional style, you have this new everywhere that you would need to go replace. Instead, use a factory function, even if inside of that it's going to do new, because at the very least you've isolated that to one place in your code base. It gives you a level of indirection. You can come back and switch its implementation details later. If you are inclined towards the class style of thing, I would highly recommend this book, simply because Eric Elliott is a very entertaining author. It's called Composing Software, and what's cool about it is he talks about a lot of the functional stuff, and then he talks about, okay, let's use those functional primitives and still build classes out of them. So he's got a lot of guidance on that. So moving into the key ideas that we're going to try and cover here. I'm going to cover the ideas, and then we're going to look at some code, and hopefully all of it comes together in a glorious, great, brilliant thing at the end, I guess. So the key ideas: pure functions, we've talked about a little bit, immutable data, referential transparency, many small functions, many small functions, and then higher order functions. So we've talked about this, the idea of the pure function. The outputs depend only on the arguments. So these are totally trivial code, right? This little add function here, add A and B, it just returns the sum of those two things. There's Z up there. We didn't touch Z, we didn't use Z, we're not manipulating Z. It's a pure function. It does not talk to the outside world. So that's cool. Immutable data. This is a big thing, and you might, if you use React, you've probably heard about this. The whole idea behind this is that if you're going to have a pure function, and the data that's being passed into that may actually have other components, may be holding on to references of that. So if the first component makes a call to a function, that function mutates the object, your second component actually now is out of state sync with that. So the solve to this is to say, well, we always just return a clone. All right? Now that works really well. There's a couple guidelines around this. If you're using huge data structures, then you should use something like Immutable JS. It's another dependency that you'd have to bring into your project. It's really awesome, but it has these really high performance immutable data structures built into it. It basically does not let you mutate it. The much more efficient way to do things, if you don't have huge data structures, is to just write a little clone function. The code base and the repo that I'm going to show you later, we have like a 5-line deep clone in there. And if your objects are all flat, it's just a graph with properties, you can use object assign. So it's very straightforward, but it is really important because if you do all this functional purity and you use all these functions, you compose it all up, but you have this problem of you're mutating the state behind other things, scenes, you're still going to blow up. You're going to stick the fork in the toaster, just like that guy did. Referential transparency, this is a side effect of immutable data plus pure functions, right? What this means is what we're showing here, right? Your program will run the same whether it's making a call to that function or you just substitute it with the value of the function. This is kind of a neat thing. It's a side effect, but what it really is valuable about is that it allows you as the developer or maintainer to reason about the software. Right? If you know that this add thing is a pure function, you're pretty certain that no other part of the system is being updated as a side effect of calling the add function. So it makes the mental model of working with stuff is easier. The idea of composing many smaller functions, right? We want to write very small functions. We want to build those and compose them up on top of things that are really well tested. We do that composition using higher order functions. And this is where I say the word function 30 times in a row. These are functions that accept or return other functions. So we have this idea here. We have a function that we're creating, add n, and what that's going to do is take a number. It's going to return a new function that simply calls our previous add function, but pre-applies it. Hopefully this add 5 thing down here makes sense. This is a new function, and it's created by calling add n with 5. And the net result is calling add 5 with the number 10 results in 15. Not super rocket science, almost completely useless, but hopefully it's showing this idea about how we can move these things together. I also highlighted map, right? This is array.map. That's a higher order function because it takes a function as its argument. But the real value of these higher order functions is where we come to doing actual composition. So this is an incredibly terse bit of ES6 syntax right here, but what it's doing is basically taking, you call pipe and you pass it a number of functions, and then pipe is going to execute those functions one at a time when the resulting function is called with some data. So that's, do things is a function that pipe together F1, 2, and 3, and then we call it with some inputs, and the output of that thing is the chain effect of all that stuff. So, functional 101. We're going to do this with just completely trivial code that's really doing nothing of any value, but again, we're going to try and talk over some concepts. So if we have an array of values here, this is probably the most brute force way that we can do things. We're going to use a for loop. We have to go in there and instantiate a number, and then we're doing some length checking, and we're incrementing it, and we have a new array, and then we're pushing things into it. And out of this, we get an array of doubles, which is good, and it's the correct answer, but that's a lot of verbosity. Even if for no other reason, you have to look at this code, you could have typed something wrong. What if you did for, I equals 1, you're going to have an off by 1 error. If you did greater than or equal to the length, you'll have an off by 1 error. There's a lot of extra code and verbosity in here. And it turns out that arrays have some iterator functions on them, right? They can do a for each. Well, okay, that's good. We got rid of that whole for loop and the extra I and all this other junk in there. But we still have this problem of we're instantiating a new array and then we're pushing things into it. I'm hoping that a lot of people in here should see what this next line is here and say like, oh yeah, well of course, we would call map. Array.map is a higher order function that is going to apply a function to each element and it returns a new array. So that did all the work for us. And we just got rid of a whole bunch of logic, a whole bunch of places where we could fat finger things and screw it up. And just mentally, oh, it's a map of this function. This is this concept of, in functional programming, we want to describe what we want, not how the computer should get it, right? It understands, by using the map function, it understands how to do the iteration. It understands that the return value is going to be an array, and it packs it all up for us. Let's look at something else here. We can have sparse arrays, right? This is, maybe the output of some other process, and one of the entries became a null. And in this case, we're just going to return the squares. Now, if you've been doing JavaScript for a while, the fact that there's a 0 there makes complete sense, because everybody knows that null times null is clearly 0. Awesome. JavaScript's fantastic like that. But really what we want to do is probably just skip that entry, right? So we're going to do that with reduce. And I find a lot of people get confused by the reduce function. So we're going to step through this, and then after this we'll kind of pick up the pace a little bit. But reduce itself takes 2 arguments. The reducer function and then an initial value. And so what we want to do here is we want an array out, so we're going to set the initial value to be an empty array. Now the reducer function itself has a signature. It's going to take the accumulator and then the individual entry that you're processing, right? So the very first time through, the accumulator is going to be the empty array. Cool. The most common thing that's going to go wrong when you start to use reduce heavily is you're going to forget to return the accumulator at the end of your block. So I always tend to write it out, stub things in exactly like this every time. I call it ACC and I call it entry, and it always looks like this. It makes it much easier. Now, what we need to do is put some logic in here to decide what's going to get pushed in. So in this case, I'm just saying if n, because we're going to coalesce it to be falsy, and then I'm just going to go ahead and push the square in there. Now also, JavaScript being awesome with the multiplying nulls, of course this would be a bad actual thing to do, because if you had 0 as a valid value up here in your array, 0 is falsy because, of course, JavaScript. But anyways, this is the idea about using reduce. Reduce is a super powerful thing though, because using just reduce you can create map, you can create filter, you can create find, and a whole bunch of other functions. So this one here is just an example saying we have an array, it's filled with objects, one of the property on the objects is color. We're going to write a little reducer to say go filter this out for me and get me just the ones where the color property is red. Of course, those objects that are in there have to be small to fit on this slide. They could be huge object graphs, they could be web maps, they could be all kinds of good stuff. But we can abstract that, right? And this is where we start thinking functionally to say, oh look, hey, I wrote that one thing to go get me a color, but I can abstract that by saying, here's a filter by function. It's going to take a property, which is going to be a string, it's going to take a value, and it's going to take the array. This if square brackets prop equals value, that's exactly the same stuff as what we're doing here, entry.color and red. All we did was just abstract the color property and the red value. So let's talk about an actual example application here. Get actually into the meat of it. So the app that I threw together for this is a very simple thing. I like to mountain bike a lot, and so trail status is important to me, and I like to check that on my phone. I do long rides, like 3 to 5 hour type rides. So in the spring, the trail conditions can change, so I like to be able to check it on my phone. The county website, great. It's a map. It's magnificent. It takes like 40 seconds to load. I want to keep moving, so I just rebuilt it. This is the actual app, nocotrailsurge.sh. So if you're in northern Colorado, may be useful to you. Probably more useful to most of you is the actual repo. This will be on the last slide as well, but it's Trail Stratus React in my personal GitHub. So let's talk about this UI really quickly. We have this concept of filters up here. Are we going to show all the trails, closed trails, or open trails? We group things into areas, and then we have individual rows for the trail and the status itself. The UI of this is React. I'm not going to talk about React, but just in case you go look at the code, there's the nav bar, there's an area. Inside of that, there is a trail component, and the whole thing is kicked off by app, just like pretty much every React application. So when the app boots, it needs to get data, and it calls an aptly named function called getData, and what gets passed in is that filter thing. What's the state of this stuff? And this is the series of things that we have to go through, right? We're going to query 2 feature services, combine the results, extract the hash, normalize things, dedupe the segments, group by area, sort by stored it, and then hand it off to React to handle the rendering. So let's go ahead and look at the data. And so this is, again, that's why I said get up close. But, you know, hopefully you're at the Esri Developer Conference. You've probably worked with a feature service before. So what we have here is we have to talk to two different feature services to get this data. The schema is not the same. It comes from the same server, but whatever, right? Who knows why? There's some extra nesting here, right? A feature coming out of a feature service has an attributes hash and a geometry hash. In this case, when I construct the query, I'm telling the server, don't send me the geometry, I don't want it. But I still have this nesting. And I like to abstract my user interface code from knowing the data source. So I'm going to go ahead and flatten that out. And then this service here has this brilliant thing. There must be JavaScript developers there because null means closed. So we have to fix that too because I don't want to show nulls in the UI and stuff like that. So how could we look at implementing this sort of thing? So in the repo, in the actual code, I have a whole bunch of these other versions of these functions and all the names are the same. So this would be kind of the most naive way to do it. I've gone and abstracted out two functions to go handle constructing the calls to these ArcGIS servers, and they're going to return promises. So I can do promise all, have an array, and then I get the results. And I could do a whole bunch of work here, right? Just like a giant wall of function, and it'd be fantastic. A downside is, as it says, right, it's really difficult to test because it's locked up in a promise chain. And there's no way to reuse it unless I'm literally talking to exactly the same data structure. So, you know, we can do better than this. So the first thing that I would think about doing here is saying, okay, well, let's abstract that promise all stuff and that detail. Let's just make one call for that. And then let's take our big wall of functions and go shove that in a function called process data, right? Now, the advantage of this is actually that now your process data function is testable. It's still a big wall of code. Your reuse is still nigh on 0, but at least you can write unit tests for it. But again, right, I've already talked about this idea. We want to compose some small functions. So hopefully, this is cool. I mean, I really like promise chain style composition because you literally can read it. Get data chain with this filter is going to return fetching the data with that filter. Then we're going to merge. Then we're doing this. And you can read it all the way down. Right? That makes it super obvious. Now we're still using a promise chain as a compositional feature, and you know, we can do better than that as functional people. We can use this pipe function. And it's exactly the same thing we talked about before, right? These are the functions, call them in order, and then our actual handler down here is fetch data and then call process data, which is the thing we just composed. So this is the less super terse version of pipe. It uses the ES6 gather, so it says all the arguments you have in here, just gather those into an array, treat them like an array, and then we return a function which has closed over that array of functions, and you just pass in the data when this thing gets executed, and we use a reduce to basically just chain those things together and keep calling the result from the previous one. So, first step, merging the responses. This is actually pretty straightforward stuff, right? We have two responses that are coming back and they're inside an array, and we need to fold that into one thing. So that's where we would use a reduce. In this case, we start with an empty array and we concat in the query response features. Now, you could also do this with object spread syntax, which is cool, but the nice thing about doing it this style, using a reduce, is that I could add a third service, a fourth service, a fifth service. By working with arrays and iterating them, you can have an arbitrary number of things in there, and that kind of future-proofs you. So if I wanted to bring in state park information, this part of the app doesn't care about it. The bottom part is just showing a unit test. This is super simplistic to test, right? I have 2 lines of organizing the data. I actually call merge features, and then I have 4 expectations. And this is, you know, there's not much code here. There's no real logic. It's just pretty bomber. Removing the nested attributes. So in these sections, I'm going to kind of show the data that's going into a function and then the data that's coming out. So in this case, what we want to do here is we have this set of attributes, and we want to simply move that one level up so that we drop that attributes hash. We can do this a whole bunch of ways, and I'm going to show a number of them. The easiest way to do it is like this. We just simply map over it. We have a simple guard clause in there to say, oh, make sure that this thing is not null and its subproperty of attributes is not null, and then return it, which is cool. But we can do a little bit better. You know, if statements in these things, if we can, we should look towards using functions to remove that logic that I might screw up and mess up over time. So instead what we can do here is use a function, a helper function called getProp. And what that takes, this is the signature of it, it takes a path, so this could be a deeply dotted thing, it takes the object we're going to check, and then it has an optional default value. So if you've ever written code that's something like this, where you need to get a value and you have a default, but then you do this like if object dot something, if object dot something something, if object dot something something something, which is really a pain, right? Because you can't just go to the end of it, otherwise JavaScript blows up and you get like can't read property of undefined. You can just squash that whole thing down into a single call. And the actual code for this is, again, it's really easy. And oh look, there's a reduce again, right? These same little lower lying constructs keep propping up. And what's really nice about them is this is super bomber code. There's very, very little logic in here. We could go through this, but basically you take the path, the deep dotting, split it, reduce over that, and then check to see if you have a value. Otherwise, if you don't, you return the default. Very powerful, very small, terse, and super robust. Talking about getting back to this, removing the nesting of the attributes thing. As functional people, we like to pass functions into things like map and reduce. We like to build those ahead of time. We know we want to use getProp, but we have this problem that getProp is going to take multiple arguments, and out of our map, we really just want to make sure we use the one, which is the entry that we're working on. So we need to do this style here, where we create a function, it's going to call the getProp function, and it's pre-assigning this attributes value in here. Now this pattern is very common in functional programming. If we want to call map a lot, we're going to have to construct or customize smaller functions into functions that are appropriate for this exact context. This is called partial application, right? And so we now have a helper called partial in this case, and this is a super simplistic one. The implementation on this, it takes a single function and one argument, and it returns you a new function that has that argument pre-applied, so that later on the next argument can be supplied. So this is a simple partial implementation. Again, this is exactly from the source code that's in the repo, so hopefully you can read that code when you go back to it. But again, it's just, you know, returning a function inside a closure with the first argument applied. And here it is to do arbitrary arguments. So if you had a function with five parameters, you can go ahead and apply 3, and then when it comes time to execute it, you can apply the last 2. So super powerful function right there. It's 4 lines with the curly bracket. That's pretty rad. Let's talk about the schema normalization. Again, we have the 2 different versions of things. What we're really going to do here is go from the uppercase names into some lowercase names, and we're going to remove a few properties and make sure that things are consistent. Instead of there's natural area and location, we want to just turn that into area. In this case, the function here is called remap fields, and we created this thing called an extract map. I just invented that, right? It's simply a crosswalk between the current property name and the new property name. We're going to use partial application because we want to construct a function that we can hand to map. So we're doing exactly the same thing we did before. We're specializing this extract properties function using the extract map that we just created. So extract props, this is a completely generic function, right? I can extract properties off one thing, transform the property names, and create a new object on the fly. This is, you know, just stepping over the keys of an object. That's pretty straightforward. The thing I wanted to get to here was yet another one of these helpers that can do useful things for you. I would also call out that this is a reduce, and instead of handing in an empty array, I'm handing in an empty object. So what this is going to be doing is creating a new object by attaching keys to it. But maybe add was the point of this, right? Maybe add is a function that takes a key, a value, and a target. And looking at the code, this is again super simple stuff, right? What does this do? If the value is not null or undefined, go ahead and attach it onto your target using the key that's been provided. And again, because we want to be good immutable people, we make clones of those things before we return them. So deduping records. Hopefully this makes sense to everybody who's worked with geometric data, right? You have a trail that's made up of multiple segments. When I show this in a table, I don't want to see each segment listed. The same trail would be listed 9, 20, 50 times. So this is just simply deduping stuff. Let's look at how we're going to do that. This is pretty straightforward. The dedupe segments is simply, again, calling another really generic function with a specialized value pre-attached. I want to dedupe this by name. The implementation, again, this is a very small, very simple function. The thing I wanted to call out here was this name matches business. This is what's called a predicate. And a predicate is a function that's going to do some form of comparison and return a Boolean. And that can be used with array.find. And the logic here is pretty straightforward. If the accumulator does not contain an entry for this current name, go ahead and add it. Super straightforward. But again, we have an if statement here. That always gives me the EBGBs in these low-level functions. So what can I do to fix that? Well, it turns out I built a parallel function. Maybe add adds properties to an object. Maybe push does kind of the same thing. You give it an object and you give it an array. And if the object is not null, you go ahead and push it into the array. And now this is a way to compose things that ends up having lots of little pieces that are relatively easy to reason about. The scrubbing of rows, right? This had to do with the weird deal of the null meaning closed. This I just did in a super simple way. Hey, let's map over it, and if row.status is not defined, we call it closed. Pretty straightforward. Grouping into areas, this is where we get into some seriously quality JSON juggling, right? You start to do things like this, where we say, okay, I have this big array full of objects that look like this stuff on the left, and what I want to do is every time I come across a new area, I want to create a new object and put that into an areas array. I want to take the value of the name, so Ross Natural Area, that's going to be the group name, and every one of the entries is going to go into the entries array. What we end up with here is each one of those sections in the UI. So the group name is your trail area and the entries are the actual trails. But the idea about using these generic names, group and entry, is because we want to write a really generic function to do this. So we can do this for any other structure that we're going to come across. This is kind of one of these units of reuse things, right? So again, we have the name matches predicate. We do this thing where we say, hey, Mr. Accumulator, do you already have an entry for this? If you do, just take the row, which is a trail, attach it into the entries array. Otherwise, construct a new area entry. Sorty McSort face, because it's about that point and showing a ton of code, you got to do something silly. What we need to do here is just simply iterate over these things and say, okay, I want to sort the areas by the property group, and within an area, I want to sort the entries by the actual name of the trail in there. So this is what that function looks like, right? We take the areas, we call this sort by, we pass it a value group, and we pass it the array, and it returns us a clone of that. And then again, we're going to map over all the areas, we're going to grab the entries, and we're going to do exactly the same style of thing in there. The actual sort by, this I think I copied directly from the Mozilla Developer Network. This is how you use array.sort. To sort things alphabetically. So there shouldn't be a whole lot of magic there, other than the fact that we're cloning. We're just using this array spread syntax to clone the context of it. And the output of this is the app, right? This is the kind of running thing. As I think I had on another previous slide at the beginning, your initial paint on this is 500 milliseconds, and 8 seconds later all the trails will paint, only because it has to make that ArcGIS server call. It is a really, 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 really lightweight application. It works great on a phone. It's super fast. So that's cool. Now, through all of this stuff, you might have seen that we're doing a couple of things. We made some trade-offs here, right? Hopefully we can see that there's a whole lot of functions that we're going to be able to reuse, maybe not just on this project, but on like all kinds of different software. There's little wee functional helpers. But we ended up doing something that sometimes people get the EBGBs about, right? Look, what we did here was we iterated over the same set of stuff many times, applying very small individual functions. I mean, hopefully some of the syntax was terse. Part of that's like to try and cram it on a screen and still be sized so anybody in here can read it. But the other thing is that those are just small functions we can reason about. So the model of piping stuff through creates intermediate arrays. So that is not a problem when you're dealing with like 1,000 things. It's a non-issue. You're dealing with 10 million things, it's a big problem. If you're dealing with a stream like of data that's just going to keep shooting at you forever, you're never actually going to have the whole array, so you can't do this style of composition. However, that's not a problem. We can use a technique that does this, where you have one item and it goes through the entire process one at a time. And this is called using transducers. And I didn't think that that was really the thing we wanted to try to get into at 4 o'clock on Thursday. That just seemed a little esoteric. But essentially what it is composable reducers. And the way that you do the composition together, the transducer, which is what orchestrates all that stuff, handles the fact that you are able to work at the abstraction of here's a whole bunch of little files that I can reason about, and the transducer is going to weld it all together and handle the iteration for you. Again, it's an abstraction that allows us to tell the system what we want, and we let it handle the how it does it, right? So that's my part of this. And so the way this worked, right, is I write a whole bunch of code, and Mike and I work together in different areas of Hub. And so I've been kind of weaving in some of these techniques into the code base. And Mike's been like, what are you doing with this? What are you doing with that? And I was like, okay, great. You can co-present this talk with me. And so what Mike's done is he's kind of jumped in. And so he's going to talk about his experience, starting to kick at the edges of this stuff.
Which one advances it? This?
That one.
Okay. So how would you, can you hear me? Is that on? I did. Hello? Does that work? It's not working? Yeah? Okay, good. So how would you get started with this? My advice would be don't do what I did. At least a couple of times over the last few years, I tried to do that and really just go all in with functional programming and understand the theory and understand big, huge chunks of it all at once, and I failed miserably every time. This time around, it could be partly because I was under pressure because I have to stand up here with Dave today and talk to you about it, but I think mostly because I took a different approach, I've been more successful. So my advice to you would be to do what I'm in the process of doing this time around. And that is basically dip your toes in. Start small. Take a handful of ideas and techniques from functional programming and incorporate them into your daily work. And that's a good place to start. Start with array.map, reduce, and filter, combined with pure functions. I think that probably if you do that, you're going to see the power of functional programming, and you're kind of going to want to be looking for more. But even if you don't, just doing that has huge value all on its own. Your code is going to be more reasonable in the sense that your future self and other developers will be better able to reason about it. It's probably going to be more testable and more robust. But very likely you're going to want to move on from there. What would be maybe a good next step? Maybe bring in a handful of functional helpers like those. Dave showed you, I think, most of those. It's a pretty good idea. You could just rip those off from somewhere on the internet or bring in a library that has those. But I think it's a pretty good idea to write your own implementation of those. I think that's an instructive exercise. It really, it enhances your understanding. Once you've done that, if you're still looking for more, and I think it's likely that you will be, that might be the time to bring in a third-party library like one of those. There are a whole pile of them out there. Those are two pretty good ones. Some resources that I used last week trying to get a handle on this. That first one, So You Want to Be a Functional Programmer, that's a series of 6 blog posts on Medium. I found that one to be a really good place to start. They're all short, and they take, the most important thing about these is that they take a very pragmatic approach. They're light on theory and jargon, and they're more just nuts and bolts. How does this work? And then another one that's a little bigger and broader, but takes a similar approach, Functional Light JavaScript. That's a book. These are all linked in the README of Dave's demo repo. Functional Light JavaScript is a book by Kyle Simpson. It's also available. You can read it for free on GitHub. Functional Light is his idea. That's this same idea of taking a pragmatic approach, leaving the theory for later, and just getting into the nuts and bolts of how this actually works and why it's good. I think, incidentally, now that I'm a little farther along this path and I'm using these ideas and techniques, I am now in a better position to go back and look at some of the theory and understand it a little bit better. But moving on, Professor Frisbee's Mostly Adequate Guide to Functional Programming is another really good one. That one, I think, I'm only about halfway through that one. I think towards the end of that, he does get into some theory, but the front half of that is a very pragmatic approach, and I found that one really, really helpful. Composing Software, Dave mentioned, I think, early in his part of the talk. It's a book by Eric Elliott. I've not actually looked at that one yet. I plan to. I do know, though, that Eric Elliott is a really engaging author, and Dave tells me that's a really good book. That's also, so it's a book, but it started life as a series of blog posts on Medium. That's Lodash-FP. That's one of the third-party libraries you might consider if you're going to go down this road. If you use Lodash, that might be a good choice. It's basically a functional-friendly version of Lodash. This is another really good one, Ramda. Yeah, I don't know. Ramda is what I call it. That one I've used a little bit. It's huge, and I found it to be pretty approachable, though the docs are good. This is a huge curated collection of functional programming resources. So once you've exhausted those first few, you might look here if you want more. This also is linked in Dave's the README of Dave's repo, Dave's demo repo.
Yeah. So what's really cool about that awesome functional thing is if you just want a few functions, there tend to be really good references in there. Like, oh, you just want like an auto curry. Well, here is a super small version of an auto curry in a gist. Copy, paste into your code, move on. There's no installing Ramda or, the Lodash FP stuff is really cool. But it tends to kind of be a little tenacious. So you're like, I want this one function, but it turns out that function uses like 2/3 of Lodash. So sometimes it's more convenient if you're focusing on keeping a really small payload size, to just go pluck the functions that you want, which is really helpful.
Another thing that's really nice about Ramda is it's got a REPL. Did I say that? It's got a read eval print loop. You can on their website. Maybe you might see it there somewhere. No, can't see it. But there's a link to their REPL, and you can try it out online and get instant feedback on what you're doing.
Right. So it's basically an interactive code environment where you can manipulate stuff, which is super powerful to get into this. So again, we just wanted to wrap it up with these core ideas. If you take nothing else out of this other than like, oh my God, that was the wrong one to be in at the end of the day. Pure functions, immutable data, out of that you get referential transparency, which means you can start thinking about things, and there's not as much cognitive load. You lose that thing of like, I called this function on this object and then some other thing updated somewhere else, I don't know why. You use all these little super small functions. Like that is literally all this app is. It's not doing a lot, but it is just a huge horde of small functions that are tied together using higher order functions. Here's the GitHub repo. If you have questions, we're more than welcome to take them. All the source code is there, and all of the utility functions have unit tests on them as well. So with that, thank you very much for coming. Happy Rubber Ducky. Hope you've had a great conference, and we'll take any questions, and hopefully they're not really hard. Thank you. Cool. Right up here.
How would you relate this to something like React.js, or ArcGIS, I'm sorry?
So RxJS is very similar to like Ramda, but it takes it's a reactive framework, and so its model is a lot around more oriented towards like the streams of stuff, right? So they use RxJS to handle the event streams. So they treat like button clicks as being there is a stream of events, and I am now going to compose a chain of things that's going to happen as a side effect of that. But that is their model, is to use RxJS to compose how the things get put together into your processes.
So would you say that RxJS is using functional programming?
Yeah, it's based on all functional principles, right? Function composition, using small functions, welding them together. I think they've got a pretty burly transducer implementation in there, and specs for how you write your reducers such that they work with the transducer. Well, there's got to be more questions than that. Everybody's awesome. All right, right here. I'm always open to ideas. I mean, if you guys enjoy this wall of crazy, I'm sure.
So, any guidance to dealing with this in a team? So you see function.
Right.
How do I know this guy wrote that function, that guy wrote this function, bring it all together?
Oh, they're like, who wrote what, and then how do you curate it? So I mean, we have a fairly large development team, and so what I try to do is, in our application, Hub is built on Ember, and inside of Ember you can do all things in all manner of different ways. And so what I've been suggesting people to do is to say, okay, look, if you're going to use a service and it's going to like make XHRs to something, that's great, but the processing of that, go and put that in a utility function. A utility function is just Ember's way of saying, hey, it's just a function. That's its construct. So we try and say, hey, you should push things over here to the edge. That's thing 0. Once you've pushed things over to the edge, oh, hey, there's this other library that we're using. It's our own set of functional helpers right now. Hey, you should start looking at using these things in Hub Common. So, hey, make sure that when you call that function, you're returning a clone, so we're not mutating state behind the scenes. So we just kind of, as people submit PRs into our application, I try and nudge people in different directions. And then there's kind of the flip side of it within ArcGIS REST JS. And within hub.js, we have these modules, and those are in there, and they're part of the code base, and they're fully documented, specifically so that it's not so much about knowing who wrote it down the hall, but hey, I have documentation, I understand how it works. And those two projects in particular mandate 100% code coverage in order to check the code in. So you know it's Bomber, and it's there, and you just kind of socially encourage people to do it.
I think also that it helps to get buy-in from the rest of the team, because Dave's been badgering us, right? But I think a lot of the developers on the team are just like, but it's hard, and it takes more effort, not so much that it's hard, but that it takes more effort.
Right.
But if you understand why and see the benefits, you're going to be totally on board.
And then you end up making these functions, things get really small and simple. I mean, it's actually kind of surprising. You'd be like, oh, we'll just do this and we'll do this. And, oh, look, I actually have no logic in here anymore. Well, that's sweet. So things can kind of generally grade that way. It's mostly just about starting. Once you start, and I think maybe it's a slippery slope.
That's true.
Cool. Yep. Ooh, another one. Okay.
So two are very specific, but the third one so you said you were showing the promise then chain, and then you said we can do better, and then you showed the light function.
Right.
Is that better in terms of just developer ergonomics, and you kind of like it's easier to kind of read and reason about, or also in terms of performance or any other aspect?
Oh, I don't think it makes any difference in terms of the performance, but I mean, the then thing is really nice. I mean, if you name your functions well, the then is like, okay, this is exactly what's going on in English, right? So there's advantages to that. Performance, it doesn't really matter which way you go. If the functions that you're calling actually are async, you're going to end up using a promise chain like that anyways. One of the cool things that I couldn't quite figure out a good way to wedge in here, there's a version of pipe that takes an array of functions. And so what's really neat about that is you can literally use logic to compose the chain of functions that are then going to be applied in a process. So that is kind of cool because you're dynamically composing things. And so that's kind of why I would lean towards, like, in my head, hey, can I do this with pipe, or can I do it with pipe where I'm constructing an array? Right. So the question is basically, when do you start writing more functions to kind of try and hide logic, right? That's one of these kind of weighing the pros and cons. I mean, this is a trivial application, right? We're not doing a whole lot of work in there. So thing 0 is, if my function is getting to be more than like half a screen long, I want to start taking it apart because it's getting too big as a general rule of thumb. I like to look for things that I know I'm going to screw up in some way, or if there's a lot of repetition. So if you have a deep object graph and you need to check to see if something way down deep exists, that's really why getprop, I started using it. And Ember has this built in to its system, but I was writing these functions that are not actually tightly coupled to Ember, so I was like, I want that. So I wrote one. That's really the thing. You know, it is a hard line, and I don't know that there's any particular rules, but if you know of a functional construct that can allow you to remove some if statements, remove a case block, and substitute it with a function that is basically not going to fail, like it's going to handle whether it's a null or not null, it's going to do its thing, then you're relying on that function and its pre-tested context, as opposed to your, typing of the same property 19 times in a row to get really deep down.
I think, yeah, if you can remove if, that's a huge win.
Right.
I made a mistake last week on a really simple if, just the logic in the if, and it's so easy to do. So if you can factor that out, that's a huge win.
So whenever I see a chance to fail by just mistyping or similar kind of thing, then I can abstract that away.
Mm-hmm.
In general, I mean, I wouldn't try to get too burly with. I mean, you saw some of those ones. This is a good place to just do map, check to see if it's null, and turn it into closed. Not everything needs a big hammer in it, but
you don't have to be a zealot.
Yeah, exactly. But that's the thing with a lot of functional programming and JavaScript stuff goes like straight to it's monads all the time, and then you're like, I don't even know what that is, and it's really harsh. But the functional light JavaScript book was the first one that I read. Was like, okay, cool. I kind of remember some stuff from Dr. Frisbee and the monads and blah, but I can start applying this in a much more graceful way. The composing software, super engaging author. I mean, that's actually fun to read, and it's good. And the first half of Dr. Frisbee is great because it's like about a crazy badger scientist thing. I mean, it's really well written, and then it gets into like deep category theory, and that's where I kind of was like, I'm just going to step away.
If you find yourself like just sort of put off by partial or whatever, like you don't quite grok that.
Right.
The way to get it is to just start doing it. Start playing with that, and then it really quickly became crystal clear to me why that's valuable.
Yeah. So if you can do things like you write the crappy function first, right? That one where I did a filter. I'm like, I'm going to get the thing out of this array based on this color red. And I look at that and be like, this sounds like something that I can abstract. So I'm going to go ahead and abstract it. I'm going to go put it in a different library so that the next time I need something like this, I can reach for that. those are the sort of things to do. I mean, that said, you know, a filter by, well, it turns out that's already baked into array, right? You don't need that one, but there's plenty of places where you can do that. Cool. The third question. You're like heroic, sir. Thank you all for staying too. All right. Sorry.
I'm really sorry if I'm stopping in on asking the question. But the third one is, I think I've written enough object-oriented programming that, you know, not just to know how to do it, but also to know how I'm sort of overdoing it or doing it wrong. So what is the equivalent to that for functional programming?
I mean, just going down the rabbit hole of getting really wrapped up around, I got to get rid of this last if, or, you know, I got to apply like some big construct in every single location, right? I mean, again, the point I tried to make at the beginning, the reason I got into this is the idea, we build large, complex software that we have to maintain over time. What can we do to reduce the complexity, make it easier to reason about down the road? There are some functions that you can write that are super, like, obviously, what am I doing here? I'm looking for null, I'm changing it to closed. I don't need big abstraction over that. It's not a high value thing. But when I'm doing like deep dotting into an object and handling all that, you know, it's not a lot of stuff, but it's just a lot of verbosity and did I screw it up? And did I, you know, 3 things in, did I mistype it? That's where I think it's really helpful. All right, awesome. Somebody over here might have, okay.
I just wondered if any of these principles have made it into JavaScript or if it has, if you have to say.
So the question was, have any of these principles made it into the JS API? So, I mean, there's nothing that prevents you from working in a functional style with the JS API. I don't know about the internals, whether they're leaning heavily on these things. To a large extent, there's performance benefits to some of these things, and then there's also performance downsides to some of them. Again, like in this case, we used pipe, and we abstract, you know, we lean towards making the code easy for us to maintain and easy for us to reason about, but at the same time, if we were to pump 50 million things through that, it would be really slow and your browser would have a huge memory footprint. The JS API deals with a lot of stuff. So they have to really balance between encapsulation, writing things in a way that's going to be performant, and then still their long-term maintenance has to come into this. So the internals of that, I'm not really sure. I mean, you can write, you know, nothing in here is using any other library. It is JavaScript. So you can do functional things without anything. Dojo probably comes with a whole bunch of built-in functional capabilities. So that's that.
With the this style of programming and immutability and things like that, does this play well with more like the state management side of things, like Redux, things like that?
Well, that's exactly what Redux's approach is, right? You build reducers, you combine the reducers together, you compose them. I mean, you're doing all that stuff, whether or not you necessarily recognize it as being like, oh, that smells a lot like this. It is completely that model, right? The entire React Redux ecosystem, and whether you're using MobX or any of these other things, it's the same idea, right? So I think it plays really well with that. Cool. All right. Well, thank you very much. I mean, it's great to have a number of people in the room who are sticking it out through a wall of code sort of an event. Hopefully that resonates, makes some sense. Thank you very much.
Well done.
Thank you.